Okay, for today, this is Quadratics B. It is the 5th out of 7 folders that we have, 7 chapters that we learn. And so let's see if you remember this stuff. First thing it says is rewrite the general form in vertex form. Ooh, how do you do that? Do you remember that? You get general, and then somehow we do some kind of hocus pocus, and then it ends up turning into vertex. You remember? It is half and square and complete the square. You're both right. Very good. Okay, so I'll help you with this one. Let's do half and square on number 1. Is it just half and square? No, there's a lot more to it, but that's the key element of it. So I'm going to rewrite it x squared minus 8x. I'm going to leave a big blank, and I'm going to move the 12 over here. Is this ringing a bell? Then you have to do half and square. Half of 8's 4, 4 squared 16. And why do I put a 16 here? Because I want to, and by the way, that'll always be positive because you squared it, right? And if it was negative 4 and you squared it, if you're squaring anything, it's always positive. Okay, why is that half and square number special? Because that'll make it, force it, to down here be a perfect square of x and plus, and oh wait, not plus, can't be plus, minus, that's right. X minus, and some of you are thinking, isn't it a plus and a minus? No, if you did that, the middle term would cancel, and we definitely have a middle term here. Okay, so x minus and minus, and then a 4 and a 4. Okay, so there's the half and square thing, and then how about this 12? It was a plus 12, and then I'm going to move it over even farther, and it's going to join with something. What goes here?
Minus 16.
Good, because we added 16. Think of this as an equation where on one side we just added 16. We now have to subtract 16 on the other side of the equation, on the other part of the equation, so that this and this will cancel each other out. Okay, and then these guys go together and make minus 4. And then, is that vertex form? No, that's a really common mistake. People think they're done. You got to put it together and say squared. The other thing is people think this is factored form. It is not. That's not included, so it's not factored form either. This is like some mutant. They are working on chimeras right now. You know what they are? They're half human, half animal. It's a chimera. Their goal is to try to be able to grow things that would grow organs for us. And you might think, well, I kind of think that's scary and terrible. Because I'm picturing like some half-human animal thing in a cage that you're going to then harvest its organs, and sounds terrible. But yeah, it sounds like the beginning of a bad Hunger Games movie or something. But it's all, if it's just grown in a lab, I feel a little bit differently about it. Like if they can actually take like a giant test tube thing and just put a heart in there and make it grow all on its own without like something around it. If you can just grow me a heart in a test tube, then I don't feel bad at all about using that if my heart goes bad or whatever. There are a lot of people right now that are literally dying on a donor list waiting for an organ, and they're gonna, it could be your dad or your grandpa or something, and if they can just grow something like that in a lab, that'll be cool. Anyway, this form is just kind of a mix of a couple forms. It's not a vertex, it's not factored, it's not general, it's not anything. Okay, this doesn't have a name. But if I put it together, yeah, I did it right. If I put it together, now it's in vertex form. All right, and next thing, I like to, if I'm going to answer a whole bunch of questions about this, I like to make a little sketch of it. Honestly, this takes you like 2 seconds if you know what you're doing. Write 4 down, 4, here's a dot. And is there a negative in front? No. So kind of generally looks like that. If you just make a little sketch, it'll help you answer all those other questions about it. So there's my vertex form. I can just put an arrow to that blank. What's the vertex then? Negative 4, negative 4? No. What is it? Positive 4, negative 4. Okay. Is it a maximum or minimum? See, my picture's coming in handy, because now I can look at it and go, oh, that's a minimum. Domain, range, once again, picture's going to come in really handy. You don't want to try to just like do that from some obscure point. To figure out the domain and range, if I see the picture, then I can say, oh yeah, it goes domain's this way, so it goes forever in both directions, so that's negative infinity to positive infinity with parentheses around it. And the range, that's from how low it is, which is at -4, to how high, and that would go to infinity. I'll let you keep finishing that off. Oh, and the zeros, what? How am I supposed to find the zeros from this? Well, if you can factor it, you should. And now I'm going to try to factor it. And if it doesn't factor, you should use the, what? Quadratic formula. That's a really important follow-up. If you can factor it, you should. If you can't factor it, quadratic formula. Quadratic formula, because the roots are the same as the zeros. You know what I'm doing there? Quadratic formula reminds you that it gives you the roots. All right, so let's try to factor that quick and just see, can we factor it? It is different than this. Again, that's not factored. So x, and then can anybody think of a smart way? You got it? PZ, what do you got? -2 and -6, and he's got it. Nice job. And once you got that, you set it equal to 0. I want to challenge you on that for a second. Why am I setting y equal to 0 to find the what? The x-intercepts are where y is 0, right? So that's why I set y equal to 0. And then if I set that equal to 0, it comes pretty quickly available to me that that's got to be 2 and that's got to be a 6. So my answers are 2 and 6. I might even say x equals. I probably would have accepted it without that, but I don't know. Just to be safe, better put that. Okay, now this one, it's tougher. I'll get you started on it. If you want to do vertex form on that guy, you got to factor out the negative first. Then we move that -27 all the way over here. Don't factor it out of everything. I know that's weird, but when on this kind, we move this over first. And now you can do the rest of it, the whole half and square, and put the parenthesis in. And then just don't forget that this negative here has to get distributed to both this thing and the thing you put in to counteract it. So let's say that you're going to put a 30 there, which is not right, but kind of close. If you're going to put a 30 in for your half and square, then you got to put a -30 over here. But this is going to hit this, so this needs to also hit that number. All right, I'm going to let you fight through number 2. And remember, there's a key. Don't think, oh, I'm totally lost. I can't figure this one out. You can always check. You're trying to learn here, and you need feedback. If you're just guessing and I think this is it, you're kind of wasting your time. You really should check. All right, I got to move on. We're going to go to this next. Wait a minute, there's another 2 problems there. You know what? I'm leaving them as optional, so we'll save a bunch of time for you. Next one. Calculate the discriminant. I mentioned it yesterday. Can anybody, actually, I'm going to ask all of you, if you remember it, write it down right now. It's one of those top big formulas you need to know for this test, and we don't let you bring in notes. So, do you know the discriminant formula? If you don't, maybe you should write it down when I tell it to you. And then on that, what you really be smart to do is make a last second study page. It's not notes you can bring into the test, but it's like last second. Wouldn't it be really helpful if right before the test I whispered, hey, the discriminant, it's b squared minus 4ac. And that'd be like, oh yeah, that helps a lot. Well, do that for yourself. Make yourself that sheet and whisper it to yourself right before the test. Okay, it is b squared minus 4ac. How many of you actually knew that? Okay, good. If you forgot it, that means you're probably not going to know it 4 or 5 days from now when we take this final. So make yourself notes. For me, I'd go off and make a little separate page on, what's it called again, Notability, and then make myself a last-minute notes page. And I'd put that on it, and then what else? What else is like a formula that that somebody might forget right before this test? Yes? For a circle, good, because not many people knew it. Okay, I'm going to challenge you right now. Don't say it. Don't say it. If you know the formula for a circle, write it down right now. Just a standard circle. And then third thing, the vertex formula. Just did it yesterday. There's a little, it involves B. If these are not coming to you now, do you think that's going to be better 5, 7 days from now? No, it's not. That's why you should write it down. Make yourself a little list. All right, This one was b squared minus 4ac. The vertex one was x equals negative b over 2a. How many of you had that one down? Awesome. And then the circle one was x squared plus y squared equals r squared. And of course, r is the radius, so it depends on the circle. If the radius is 5, then you'd say 5 squared. And then what if you want to move your circle to the right or to the left or to up and down? That'd be in here. I want to move it right 1, I'd go like minus 1 in there, and then move my circle right 1. Okay? These are all also formulas that would be good to know for the ACT test. They do not give you a formula sheet. Neither does the SAT. So, memorize them now. All right. And the discriminant, this b squared minus 4ac one, tells you how many solutions you have. If it's greater than 0, then there's 2 solutions. If it's less than 0, there's no solutions. Why? Because then b squared minus 4ac is negative and it's underneath the square root and you have a square root of a negative. That's why there's no solution. And what if it's equal to 0? If b squared minus 4ac is equal to 0, yes, then there's 1 solution. And what is it? Yes, 1 solution. And it's the vertex. Let me show you what I mean. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, I'd have you put that on your memorized sheet, except I think almost all of you have that one down. Okay. But do you know if this discriminant part right here comes out to 0, that all cancels, and that's your vertex, negative b over 2a. Remember that? Okay. Lots of stuff to know about quadratics. They keep coming up in pre-calc too. It's the #1 function we use in pre-calc is the x squared function. I mean, we go further too, but I'll often come back to that one. All right, so what's the discriminant on this guy? Well, it's b squared minus 4ac. So what is b squared? Negative 12 squared, which is 144 minus 4 times, and a lot of people will mess up this part because of the negatives, so I always recommend parentheses right there, because that's what variables are, is open parentheses. Now, A is negative 3, and C is negative 9. Do you see there's actually 3 negatives all in a row there? So when we're done getting this, do you get we're going to do a subtract? Because there's 3 negatives. Yes? Yes, you may. All right, so 9 times 3 is 27, and 27 times 4. Any smarty pants already figured out 27 times 4? All right, I'll do it off to the side here. Am I doing that right? I think I am. What? 108? All right, thank you. So if it's 144 minus 108, I do need to finish that, but I can already tell it's going to be positive, and therefore it's going to have how many x-intercepts, how many zeros, how many roots. If it's positive, it says right here, there's 2 solutions. All right, but what is it? 144 minus 108, help me out, 30-something, 36. And that would have worked nice because it's underneath the square root, but don't square root it. A lot of kids think it's b squared minus 4ac and then you square root that. No, it's just b squared minus 4ac. All right, now you need to practice that, so you should do I don't think you need to do a lot of these, and some of these numbers are pretty big. Let's do 7 as a lucky 7. All right, moving on. Again, this whole section. Oh, no, this one's different. These are about not finding how many solutions does it have. When we hit number 8, it's actually getting the solutions. So this one, as always, if you can factor it, you should. What if you can't factor it? Say it fast. Quadratic formula. That's got to be this follow-up you need to know, because not everything factors. If you can factor it, you should, and then the answers will be easy. You'll set this equal to 0 and that equal to 0. What if it's like this? It's not, but let's say it was. Kids go, oh, so the answer is 4 and 5. The answer is 4, but it's not 5. They just think it's always the opposite of that number or something. I think that's what they're thinking, but no. I got to actually write an equation for this. 2x minus 5 equals 0, and then solve it, etc. purposely did this one wrong because I know you know how to factor. And if you can factor it, you should. All right. And it asks for solutions right there. And then it asks for a couple other things. Simplified radical form. That means if you got an answer like this, 2 plus and minus the square root of 8 all over 4, you can't just leave it that way. That's kind of hard. And it involves like 3 different things. That's why it's in the top 20. So again, if you're studying for this final, you're also doing top 20 stuff. Or another way to think of it is, what if over the weekend you studied for a top 20 and you took it on Tuesday? That'd be great studying for this final because that's one of the top 20 right there. So if you wanted to do a last second top 20 to try to earn the coin, that would also be studying for the final. All right, and you don't have to, by the way, like have me put one in the test. You just show up. You show up in the morning, say, I want to take a top 20. I grab one, give it to you. It's that easy. If you want me to put it in there so you can take it after school, I can do that too. Just got to ask. All right, so that simplified radical form is simplifying those kind. And then decimal form, well, if you're allowed a calculator on the test, which I'm still processing. I get confused because one of my tests is calculator allowed and one isn't, so I don't want to go on record right now as saying which one it is, but I can tell you this. If they asked you for a decimal, you'd have to have a calculator because we don't, you know, like when you have the square root of 7, there's no way to do that without using a calculator. At least for you, there's no way to do that without using a calculator. All right, so if it was 2 plus and minus root 7 over 5, it's as simplified as far as it can go. And if you needed decimals, you get a decimal for that, and then you go 2 plus the decimal divided by 5, and 2 minus the decimal divided by 5. All right, so I think you should definitely do one of those, so please do number 8. And if you feel like you need more practice, do more. Okay, this is the same exact kinds of concepts, number 10 and 11. Number 11 is worth doing because it's different. How is 11 different than the other ones? It's not set equal to 0. Very good. You got to make that tweak first. You can't try to stick those numbers into the quadratic formula or factor it or whatever. It won't work. Got to set it equal to 0. All right. I think this one's worth doing, number 12. It'll make you think about the discriminant in a different way. Kind of backwards. Instead of saying, here's the thing, tell me the discriminant, it's more like, here's what the picture looks like. Which discriminant must it be? Kind of like goes backwards. All right. Now we get into the kind where you absolutely would need a calculator to be able to do it. And that's the kind where you type stuff into the calculator and figure out what its highest point is and all that kind of stuff. So grab your graphing calculator. If you don't have it with you, you'll have to borrow from me. I'll pause for a minute. Okay, so I've got my equation typed into my calculator on the y equals line. And then it asks me for the following questions. How high is the object after 1.3 seconds? I want you to just think about this for a second. 1.3 seconds has to go in this equation somewhere. Is it the h of t, which sounds kind of like height and actually is height? Or is that the t, which sounds like time and it actually is the time? So do you get how you put the 1.3 right there? Okay, now there's a way to do that on the calculator, or there's a way to just like go, okay, I got to put a 1.3 here and there. And that totally can be done with the calculator too, by just typing in negative 4.9 times 1.3 squared plus blah, 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 blah. All right, but I think it's pretty cool to do this with the calculator. So I'm going to show you how we could do it with the calculator. All right, so I'm going to go to my graph, and everybody hit graph. Hopefully you can see it. Okay, mine is looking pretty strange, so I'm going to go to Window and say, oh boy, my window's all messed up. If your window's all messed up, Zoom 6 is your standard zoom. Gets you back to normal. Hit Zoom 6. Zoom is the very middle button right here. Zoom 6 will kind of get you back to normal. And then does anybody remember where all these calculation things are done? Yes, second calculate. It's right above trace. It's right here. See that little word calculate right there? So, second, I've got to get rid of my writing now. Second trace, which brings you to the calculate menu. Now, is it Did they give me a 0? No. Did they give me a minimum? No. Did they give me a maximum? No. Did they give me a value? They gave me a value. Yes, they did. And hit enter. And here's how you can tell. It always asks you a question. See at the bottom how it brought up x equals blinky? Okay, so it's asking for x. Isn't that what x is? Yeah, x is 1.3. So I'm going to type in 1.3 and I hit enter. And there, it gave me the answer. Y equals 6.8 blah, blah, blah. I'll pause for a second. Okay, so how high is the object after 1.3 seconds? I'm going to just keep it simple because I know some of you guys could spend the entire rest of the hour just on learning how to use a calculator well. I want to go with, you can just use a calculator to do the math part. You don't have to do these complicated second calculate things. You can just stick in 1.3 right there, and any one of you knows how to type that into a calculator. Just typing this in right there. So, at what time and what height does the object reach its maximum height? As soon as they said maximum height, my brain said vertex. Did your brain say vertex? If not, that's something to put on your sheet. Maximum height or minimum height, that's vertex. And as soon as I had vertex go into my head, I said x equals, do you remember it? It's not the whole quadratic formula, it's part of it. Negative b over 2a. So I'm going to put that into my calculator, x equals negative b over 2a, and I will figure out, probably have to put batteries in it. Just take 4 with you back to your desk. And negative b over 2a in this case is negative 4.5 over 2a, which is 2 times negative 4.9. Remember, all I get out of this is x. X equals all that. How do I figure out the y? Plug it back in for the x is, in this case, like the time. So I plug it back into the equation where the t is. Negative b over 2a gives you that vertex. And x is the time. So if all they wanted to know was what time, then I'd be done, because x is the time. And that number right there is the time. All right, how long does it take for the object to reach a height of 0 meters? What the heck are they talking about? Well, it started at 9.3 meters. It went up because they threw it up, and then it comes back down again. And they didn't ask about like where does it hit a height of 0 meters? By the way, 0 meters means hits the ground, right? But they're asking about that spot right there. Isn't that a root? So unless you think you can factor that thing, use the quadratic formula. You won't want the negative one, right? Because the negative one, which is over here, doesn't make any sense in the context of the question, negative time. Maybe someday you'll be able to go back in time, but honestly, I hope we can't. Just even though I'd like, how about this? If only I could go back in time, cool. I don't want other people to be able to go back in time. That would really mess things up badly. All right, there's been a lot of movies made about that. Okay, so this is hard enough that you might be tempted to say, oh, I'm just giving up on that. That stuff's too tough. Okay, but it's very likely to be on your final. Unless you can afford to give up like 4 points worth of questions on your final, then don't just give this up. If you have to, go back and watch this video again to remind yourself how to do this stuff. Okay? All right, and I'm going to assign that you should do another one just like it here, number 14. All right, and this one does include something slightly different, so I want to look at number 14 with you. It involves this thing, when will it be 30 meters off the ground? If I make a picture, remember, picture's worth 1,000 words, it would be smart for me to go like this and say, 30 meters off the ground, that's like a line at y equals 30. Or another way to say it is if I had the equation, which we will, you can write an equation for this, because it's always negative 4.9 t squared or x squared. Here's where the velocity goes, and here's where the starting height goes. Did they tell me the velocity? Yeah, they did. So that goes in here. Did they tell me the starting height? Yep, they did. So it goes here. Then, when they told me 30 meters above the ground, this is just classic ACT stuff too. You got to know, where do you put it? And everybody tends to want to put things in the X. But X is time. Is 30 meters a time? No. So that only makes sense that the 30 meters should go in the other thing, which is here, the height. All right. Those are my hints to help you with that one. All right, and that's it. The end of that, which is a good thing because it took a long time. But I warned you, quadratics thing we did yesterday, that was the easy part. This is the harder part. This will be the R3 questions. And unless you want a C, which you can get C just with the R2s. You just get a great score on the R2s, you got a C. But unless that's good enough for you, you need to learn those. All right, I'm going to pause for a minute while we find the next folder. Here's higher degree polys. So first of all, this is list all the possible roots. I'm going to just give you the formula. Another thing for that sheet that you could be looking at right before you start the final. F con over F co. Factors of the constant over factors of the coefficient. That's the constant. This is the lead coefficient. What are the factors of the constant? 1 and 7. What are the factors of the coefficient? 2 and 1. And then I have to divide everything by everything. The tops have to be divided by the bottoms. So 1 divided by 2, 1 divided by 1, which is the same as 1, 7 divided by 2, and 7 divided by 1. And then don't forget to put plus and minus of all of them. There. Once you do that for part B, there'll be a big list because 12 has a whole bunch of factors. Okay, next thing. It wants me to factor. Basically, this was the factoring chapter. This is the one where you factored with synthetic, factored with long, that kind of stuff. And I think synthetic is the one you should focus on because almost every problem can be, the big ones can be solved with synthetic. All right, so if you're just given this and you're not told anything that goes into it, well, it's the factors of the constant divided by divided by 1. So basically, it's got to be 2 or 1 or what? Besides 2 and 1, there's also -2 and -1. Okay, good. So I'm going to check 2 and see if it works. Would you please do synthetic with me on this? 1, 1, 2, 2. And wait, stop. Just be smart. If I keep adding and multiplying and adding and multiplying, do you get, I can't possibly get a 0 at the end? Think about that. They're all positive numbers. It's just going to get bigger and bigger and bigger all the way to the end. There's no way for it to be 0 at the end. Okay, so that can't work. So maybe -2 can. Try -2. And if -2 doesn't work, try -1. Because, again, if you're multiplying and adding and multiplying and adding and multiplying and adding, how are you going to end with a 0? Can you unplug and can you put your cell phone on my desk? I need to see a little better attention. How do you just set it right here? I see why you left me your hat last time. Okay. Did -2 work? Yes or no? Can we get to the end and get a 0 or not? Nope. All right, let's try -1. I bet you -1 will work. So I drop it like it's hot. Multiply, add, multiply, add. Oh, wait. Yeah, that's right. Multiply. Whoo, it worked. It ended with a 0. Remember, that means that you now have confirmation it worked, but you don't actually have the answer. This part right here tells me factored form of what? What does that turn into? X plus 1. How about this part right here? X squared plus 2. There we go. Now, can you get the roots out of this? Yeah, that's really easy. The root is -1, and that's real. But the other one, not quite as easy. You got to set x squared plus 2 equal to 0 and solve it. Hint, there'll be a root, and there'll be a plus and minus, and there'll be a I, and there'll be all kinds of stuff. All right. There, I helped you a lot on number 2. I think you should do at least one like this. I would think you would want to practice one like that. So let's have you do, you know why this one? I'm just going to tell you ahead of time, there's an X in everything. Do you get how that changes stuff? You got to factor that X out. And that means right away, if there's an X in everything, everybody factors it out and then forgets about this lonely little X they factored out. It's in the factored form then. There's an X because you factored it out already, right? And then there's going to be more stuff here, but don't forget there's an X that gets factored out of everything first before you even started. Then, a lot of times things can factor normally or factor by grouping. Don't forget those ways of factoring too. It's not all about synthetic. Factor by grouping is really handy. So I'm going to assign 1 that does factor by grouping, and that's number 6 here. If you want to fight through it with synthetic and find all the factors of 27 and blah, 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 go ahead, but it factors by grouping. Way easier. That's this kind where you factor this part, and then you factor that part. Yes, sir. Is that also factored by grouping? Cool. Good to know that you can do it with synthetic too, though. I recommend if you see that it looks like it'll factor by grouping, that you do it by grouping because it's easier. But it's up to you. If you want to do it, it doesn't matter. It's kind of like saying, is it better to walk to work or drive to work? Well, it kind of depends. Sometimes it's not the exercise, you should walk to work. Want to save the gas money. If you need to get there fast, you probably should drive to work. Kind of depends on your opinion. So you pick any way you want to factor these puppies. All right. Now, there's obviously a ton of them, but I think you should do one beast, and that's number 10. Okay. This stuff is easy, and it's easy enough that you could forget to know it and then all of a sudden bomb the test on it. And I'm going to do 11, and you should do 12. Ready? Watch number 11. The degree of that puppy, I look for the biggest one, not the first one. Not this, this. So then that's degree 6. The leading coefficient. And once I knew that this was the key term, I circle it. He's the boss. The other ones don't matter. I just look at that one. Okay? And now that one tells me leading coefficient. A coefficient is the number in front, -3. The end behavior then is that negative tells me what about my function? The right side goes down. This part here tells me the right is down. Okay, so right, down. Then the degree, the 6, this thing, that tells me even means they're the same, odd means they're different. Okay? So this is even, so that means it's the same. So if it was down, it's going to be down. That stuff's pretty easy, but I mean, it's going to count just as many points as a hard problem. So you know what I mean? Got to know how to make sure you've studied the easy stuff too to not give up some of the easy points. All he needs is 75%, but if you miss it because of one of those, all right. When I say 75%, I mean it's Marzano style grading. So 75% on the easy ones and 75% on the hard ones on this test will get you an A. All right, last section. Yay, I think. I'm going to double check that. Yeah, pretty much last section. So, do you guys recognize that that's a double and that that's supposed to be a snake? It's kind of weird looking. If it's like that on the test and you're like not sure, Mr. Server, is this curve supposed to be a snake? You could ask me that. That'd be a legal question to ask me. Okay, and if it's a snake, though, I wouldn't be able to tell you how many degrees that is. Do you know? If it's a snake, it's degree 3. Good. That's a triple root, it's called. All right? That's a 1. That's a -1. So then my roots are -1 and 1. Then that means if I was going to write this thing in factored form, I have 1 with -1. Opposite of that because it's on the inside. And then with +1. Now, it's going down on the right. Needs a negative in front. Last topic. You made it to the end. Don't pack up your stuff yet. Pay attention. Do you get from here all the way down, it's decreasing? Then I go from this spot, which is 0, 2, and I use the x of it, and I say it's decreasing from 0 to, remember, it's from here to where does it stop decreasing? Never. From there to infinity. Some kids go, but it's going to negative infinity. That's a y thing. In the y direction, it's going to negative infinity. But these are always x values when you're doing your increasing and decreasing intervals. That's the most common mistake, and we will, if it's multiple choice in this section, we will throw in one of them with the y and one of them with the x to see if you know which number to pick. Because people often say, oh, it goes from 2 to negative infinity. Those are the y values. The x values where it's decreasing is what you want. So we wanted 0 to positive infinity. Question, yes? All right. You got to read from left to right. I know this sort of looks like it's going up, but if you read from left to right, that's decreasing in that zone. Okay, so to this spot, which is at negative 2, 0, and you use the x values, I would say it was decreasing from negative infinity, which is like way over here, until it hits negative 2. All right, that's all a review I can do for you for today. We'll have more on Tuesday. Keep getting your homework done.